All right, welcome to section 4.5. In section 4.5, we're getting into the second half of chapter 4. The second half of chapter 4 starts at looking at the graphs of sine, cosine, tangent, and then secant, cosecant, cotangent functions. So this is always that scary part where we're going to be talking about graphing, sketching by hand. We're going to jump right in. I will warn you, these two videos are going to be sort of along, the notes and the examples. Just, looking up here, it's a long section. So recall that for sine and cosine functions, the domain is all real numbers. Again, that symbol for all real numbers. And the range is actually just -1 to 1. And if you think about the unit circle and you think about the answers that you get for sine, cosine, the answer is always going to be something between -1 and +1, including -1 and +1. So when we talk about sine and cosine, we never get an answer outside of that. Both functions have a period of 2 pi. And what that's saying is the function is going to start repeating itself after 2 pi, after a full unit circle, which is how long it takes for the function to repeat itself. So if we wanted to graph a sketch of y equals sine x by using some values that we remember from the unit circle, well, the sine of 0, again, this is the y value on our unit circle, the y value at 0 is 0. The y value at pi sixths is 1/2. At pi fourths, it's √2/2. At pi thirds, it's √3/2. At pi halves, it's 1. At 3 pi fourths, it's √2/2 again. At pi, it's 0. At 3 pi halves, it's -1. And at 2 pi, it's 0. So if I wanted to give a sketch, an idea of what just sine x looks like, here we'll draw this, and we're going to go from -1 on our y values to +1. When x was 0, y was 0. When x is what we're going to call pi sixths, x was 1/2. When we were at pi fourths, we had √2/2. √2/2 is just going to be a little bit more, pi fourths, than that. At pi thirds, we have √3/2, which is going to be a little bit more than that. And at pi halves, we have 1. So this is pi halves, which means, about here we're going to have pi. 3 pi fourths then right in the middle of this. At 3 pi fourths, we have that same location as at pi fourths. At pi, we have 0. At 3 pi halves, we have -1. And at 2 pi, I've got 0. And you can notice I've sort of spaced this out to make sense. If this is pi, here's about 1/3 of it. Here's about 1/4 of it. Here's about 1/6 of it. Here's half. And if this whole thing is pi, then here's 2 pi. Now, if I were drawing the function between these, you get this sort of S-shaped curve. This is what sine is going to look like. So all I did there is I took unit circle answers to give us a sketch of sine. We're going to do the same thing now with cosine to give us an idea of how a cosine function looks. So if we're talking about cosine, we're talking about the x values from the unit circle. However, this is still going to be y when I plot my points. But these are the x values from the unit circle. So when x is 0, that coordinate is 1. When x is pi sixths, that coordinate is √3/2. Pi fourths is √2/2. Pi thirds is 1/2. Pi halves is going to be 0. 3 pi fourths is going to be -√2/2. Pi is going to be -1. 3 pi halves is going to be 0. And 2 pi is going to be 1. So now if I'm going to go and sketch this, Let's say that right here I have pi, and right here I have 2 pi, and here I have 1 and -1. And I'll fill in some of the easy ones right away. 0, 1, pi halves 0, pi -1, 3 pi halves 0, and 2 pi 1. You can maybe tell what the shape of this is, but just to help us out, pi sixths, pi fourths, and pi thirds are inside there. And I get 1/2 root 2 over 2 and root 3 over 2. 3 pi fourths, I get negative root 2 over 2. So root 2 over 2 I said was like right there. So it's just going to be in that negative area. So now if I'm looking at this, the overall, oh, I totally missed, I'm sorry. The overall shape of this, okay, well, I sort of missed again. That's just, I'm sorry. I don't know how to, there we go. I teach math, not art. So this is like our regular cosine function. It's sort of going to look like a sine function, but just only one piece of it. However, it is spanning the same distance, 2 pi. So you've got sort of this S-shaped one and this sort of U-shaped one. However, keep in mind these do not come off like that. They're actually going to come back down. So talking about the sketching of that, we don't want to go and reference the unit circle every single time. All of these graphs are going to have 5 key points. The first is going to be the starting point. And what the starting point is going to be is the beginning of the period. In both of these cases, the starting point was 0. So that was one of our key points. The last one is going to be P, where P represents the end of the period. So back 3 slides ago, all the way in the beginning, we said that both sine and cosine have a period of 2 pi. So P, 2 pi, was in our list. And then you have the middle of that. So somewhere between 0 and P would be P over 2, or 1/2 P. The middle of that would be P over 4, or 1/4 P. And the middle in between these two would be 3/4 P, or 3P over 4. You should probably switch that. I wrote that wrong. And what P represents is the period of the function. So in these past two, sorry, wrong way. In these past two, I had 0, 2 pi. The midpoint of that is pi. The midpoint of that is pi halves. And 3 times that is 3 pi halves. So these are my 5 basic points. When we sketch these, we're going to be referencing those basic points all the time. Something to keep in mind is for a cosine function, those y values are going to go in that order for those basic points. It's going to go 1, 0, -1, 0, 1. Notice 1, 0, -1, 0, 1. For sine, again, looking at those same ones, those y values are different. It's 0, 1, 0, -1, 0. This is stuff that you're going to want to memorize because it's going to be stuff that we're going to use. The order of those 5 points. Notice they're different. All right, moving along. We also talk about the amplitude of a sine or cosine function. What amplitude is going to represent in sine or cosine is half the distance from maximum to minimum. So half the distance from maximum to minimum. Or how far up or down the graph travels from the middle. So that's just another way of thinking about this, is how far the graph travels up or down from the middle. If we had some function y equals a, where a is just some coefficient, sine x, or y equals a, where a is just some coefficient, cosine x, then the amplitude is just the absolute value of a. So essentially the coefficient, or the absolute value of the coefficient in front of the trig function, is going to give us the amplitude. If a is a negative value, what that is telling you is that there's a reflection over the x-axis. So throwing this all the way back to section 2.4, we talked about reflections, and we said if that negative is in front of the function, that means that I'm reflecting over the x-axis. So this still holds true with trig functions as well. Then we talk about the period, because the period will not always be 2 pi. The period is the amount of x values to complete a cycle. So essentially, it's how many x values are going to occur before this function is going to start repeating. If y equals a sine of bx, or y equals a cosine of bx, then the period can be given by 2 pi, since that's the basic period for sine and cosine, over the absolute value of b. So if there's some coefficient of x, that is going to affect the period. Frequency is going to be the reciprocal of period. We won't look a ton at frequency, we'll look at it a little bit, but frequency is the reciprocal of period, and it's more commonly used for wave functions. So when we talk about something like radio waves, microwaves, those can be modeled using trig functions. And when we talk about them, we talk about frequency, which is just going to be flipping that period over. All right, we have some examples that, go watch. They're always helpful, but now we're skipping ahead a little bit, so catch up here. Slide 11, shifting. If I have y equals a sine bx minus c plus d, so y equals a sine bx minus c plus d, or y equals a cosine bx minus c plus d. So for sine and cosine functions, the value of c over b would represent a horizontal shift. Now this one is particularly important because it's tricky. You're used to, when we see this, like, okay, it's still counterintuitive. So if I had something here, we'd be like, oh, okay, we're going to shift to the right, c. But with trig functions, it's actually c over b, because b is affecting the period of which, or in which, this is going to repeat. So horizontal shifts are never just going to be c. It's going to be c over b. If b is 1, perfect. The value of d represents a vertical shift, and that is not counterintuitive. If I see plus 7, I was shifted up 7 units. When graphing trig functions, first plot the 5 key points, then shift each point and connect with a smooth curve. So this is going to be sort of stuff you'll see in the examples, is how I go through the graphing of trig functions. And there's multiple ways, but I go through sort of what we did with logarithms, where we're going to set up a table and do things with that. If you'd like to do it graphically, you can graph the original function first and then adjust that. All right, so again, just be careful when shifting horizontally. When I look at this, y equals sine x minus pi, that would be a shift of the basic sine function to the right pi units. Because if I did c over b, I would have pi over 1, which is pi. So that would mean I'm going to the right, pi units. However, if I was looking at this one and did c over b, I would have pi over b here is 2, which would mean that this is only a shift to the right half of pi, even though this just says pi. It's the ratio of these two. All right. In terms of our notes, that is totally it. Sort of a lot of information there. So I recommend, even if you're not going to watch all the examples, maybe just go watch one. That examples video is going to be long because these take a long time to do each problem. And I want to be very thorough with you. But try one out. Just, watch it, see what I'm doing so that you sort of walk in a little bit more prepared or a little bit more of an idea of what you're walking into. Bring any questions that you may have about any of those definitions.